So, welcome everyone. My name is Daniel Mellado, and I'd like to introduce myself really quickly. I've been working as part of Superfluidity this cycle, and I'm as well a core reviewer and a PTL for the Career project. So, let's go a quick introduction. We have a research framework within the EU, which is called Horizon 2020, which is basically the biggest EU research and innovation program, and it has nearly 80 billion euros of funding available, which basically it has more focus on private and public sector interaction, basically excellent science like FAT, American actions, industrial leadership, and information and communication technology, which is where this Superfluidity project kicks in. So basically, Superfluidity aims to provide a converged cloud-based 5G concept, which would enable mobile edge use cases. So we have been a big consortium. Basically, we have, of course, Red Hat, but besides us, there's BT, Nokia, Telefonica, a lot of universities such as the Ben Gurion One, University of Bucharest, Ben Gurion, Alcatel-Lucent, Intel R&D Ireland, and so forth. So what do we aim for is to instantiate services on the fly and run them anywhere in the network. And that means either core aggregation or edge networks, and ship them transparently to different locations, such as you can start with a service such as an FFB. Think of the easiest one, which would be just a firewall. And for instance, if you start with a firewall on the edge core, on the edge network, you might want to move it to the core or the other way around. So basically, this would aim to allow services, some of those, not everyone's, such as you might have a video streaming application, which would be much more efficient if you moved it to the edge network, and you could use and leverage on its much less delay. So things that we have been working on is that we found out that the NFP challenges that would be going on this project would be for anything that you would do on the conventional FB, you'd have a lot of long provision times. You'll have to rely on rigid and cost-ineffective devices. I mean, it's all quite rigid. So we wanted this to be much more flexible, and that's a little bit why the name is Superfluidity, to be able to seamlessly translate things on different networks. So think about this, like a 5G network, basically, it has evolved from, you have on the left your usual thing. So we have been evolved to SDN controllers. Here we have also in the radio access network, which has been evolved, its evolution to centralized office data center. And we have, and this is what interests us quite a lot, MEC, which is the multi-edge access controller. So basically, using this MEC, we would be able to instantiate applications. Basically, and by applications, I mean, again, any NFV thing in any kind of network. So one of the things that we were working, because on this kind of research projects, there's a lot of different aims. So we were mainly working on the work package that aimed for the deployment on this system. One of the things that we were doing is we wanted to have an NFVO orchestrator. So basically, we use ManageIQ, where we were working on enable Ansible things, to use ManageIQ to speak and deal with both virtual machines and containers. We would create virtual machines for the services that would need a bigger VM, and containers for the much more lightweight services. So there comes Career, which is basically a bridge networking in between OpenStack and Kubernetes, which we use basically as a centralized networking model. Under the hood, of course, we have KVM and OpenVSwitch and Docker for the containers. So again, let me go here. This would be like the big deployment, but let me introduce you to how this would be. So on the upper layer, we would have ManageIQ being able to deploy applications such as the MEC or TOF. In any case, this TOF is a acronym for traffic offloading. And ManageIQ would speak with OpenStack, and OpenStack would use Git templates as well as Ansible playbooks who would leverage on those to deploy both CRAN, the Cloud RAN, and MEC controllers, EPC, and whatever. And then, again, Career would be the glue in between. So as our contribution to this project was mainly contribution to Career, I would like to go and quickly highlight the things we have been working into. So first, we were working and enabled Neutron QoS to limit the max bandwidth between different clouds. We were also working and setting up OBS firewall to have an OpenFlow-based firewall that we could work with directly. One of the things that we needed to go with Courier was basically the first one, to be able to fast deploy ports. For this, we were working on a feature called port pool, which basically enables you to create a pool of ports pre-created, which would be really fast. So you would be able to spawn thousands of containers if you would like to, and we would get a port per container just directly from the pool. Also, we were working on enable nested container, basically using VLAN-aware VMs and Mac VLAN interfaces for the ports. The idea overall, in any case, and let's recap with this, is that we had managed CQ at the very top as an NFVO orchestrator, which uses Ansible, collaborates, and deploy templates on both kind of clouds, and then Courier gets all the thing. So here is an example of the port pool feature that, if you see, we have been able to maximize the amount of ports per second that we are getting, and that makes it much faster, which would really make use of it for applications such as a streaming server. For instance, one of our partners, which is Unified Streaming, did a showcase for this in Brussels last week, where they basically wanted to deploy a streaming server in both edge and core networks, and seamlessly moved it for VM to containers, and the network was awesome, where we could just get them to deploy, get the MEC, traffic offloading thing, and all the things there. So also, we had a lot of partners because I was mainly focusing on the work that we did in Red Hat, which is just deployment and orchestration. But for instance, the guys from NEC were working on improving VM boot time by usage on unikernels. Intel has been contributing applications such as KPI and metrics. We have been able to develop a lot of papers out of these. For instance, there was one that got accepted in the IEE Cloud conference. Also, we were able to use OpenShift Ansible to liberate all the work and Courier to use OpenShift, which is called by ManCQ, and it would deploy directly all the Courier containers to handle all of this. And we have a lot of contributions. So this project was finished like last week, as I said, and we were able to get an awesome result for the European Commission, which granted us an excellent rating. And sorry for being quick, but I think in less than 10 minutes, this is all that I can speak about Superfluidity. So if you have any questions, feel free to hop on and ask me, because they are going to stop the recordings. So thank you.